Good morning, good afternoon, or good evening, depending on where you're listening. This is Dan Turchin, host of AI and the Future of Work, CEO of Insight Finder, the system of intelligence for IT operations, and executive chairman of PeopleRain, the AI platform for IT and HR employee service. Now, as you know, each week we explore how AI is defining the future of work. We learn about innovative new technology from entrepreneurs like Darius from Meritas, who was here a few weeks back, or Alex from Josh.ai. We learn what's newsworthy from journalists and analysts like Kieran Ray and, of course, Charlene Lee, the analyst. And we learn how technology is being used from CIOs like the great Mark Settle and venture capitalists like Bill Davidow, the legend from More Davidow Ventures. But I got to say, it's been a while since we discussed the technology behind those big ideas and big stories. Well, today I'm excited about the conversation we're going to have with Haixun Wang, who has been an integral part of developing the algorithms and wrangling the data as a VP of engineering at some amazing category-defining companies, including, imagine this list: IBM, Microsoft, Google, Facebook, Amazon, WeWork, and in his current role at Instacart. Dr. Wang received his PhD in computer science at UCLA, and throughout his career has really been a part of some truly iconic companies and cultures. I wish we could have this podcast last about 8 hours. Unfortunately, we won't have that much time. So let me hand over to Haixun. Welcome to the podcast. Tell us a bit about your background and how'd you get into the space?
Thanks, Dan. I'm very glad to be here to have this conversation. I think it's going to be interesting. Yeah, so as you mentioned, I've been with quite a few big companies, big tech companies. I started with IBM after my PhD, and then I moved to Microsoft, Google, and Facebook. But more recently, I've been with startup companies. Spent 2 years with WeWork, leading the applied science team, working on quite a few different things, ranging from pricing, marketplace, to even things like robotics. Yeah, it was a very wild ride in retrospect. And currently I'm with Instacart, working on using machine learning to improve almost every aspect of the business, especially the effectiveness of our algorithms and also the efficiency of the business. So this is mostly in my current role is mostly solving problems in the domain of e-commerce and the delivery company. It turns out that machine learning has been super successful in these domains, and decades of work have been devoted in these areas. So yeah, so I'm just solving all these interesting problems in the domain of e-commerce, I guess.
Now, in Silicon Valley, we very casually talk about every company being a technology company. Well, your last two employers, one of them rents office space and the other picks up people's groceries and delivers them. Talk about, what do we mean when we say every company is a technology company with respect to the problems that you're solving for these physical businesses with data?
Yeah, that's a really good question. I remember when I was at WeWork, there was a certain period of time, like people have always been questioning, whether this is a technology company and what it means when you claim yourself to be a technology company. I think there are many, many different definitions of, being a technology company. One thing I would like to point out is actually how you scale. How does the company scale? Does it scale with the support of technology? like the technology is really the major, force that driving the scaling up of the business. If that is the case, I feel I would like to think of the company as a technology company, right? So, Instacart, we use technologies to um, at least for the first thing that like we actually enable the grocery stores to do online business to help them to move their business to the digital world. And we do this for one company, and we do this for another retailer companies, and we can do this for any number of companies, any number of retailers, no matter how many stores you have across the country, right? So I think this is basically the scaling up that I have been talking about. I feel like technology is really the driving force behind this kind of capability. And if you do that, I would say this is a technology company.
Now, in an interview that you did when you first joined Instacart, you talked about some of the challenges that Instacart has that they can address with data. Like, I think one of the examples you gave is, when you were first introduced to the business, you were asking, well, how many deliveries can a driver do in a day, and what's the capacity of their car, and how much time do we need to allot for them to be in a store, and what insights do we have about inventory and things like that. It would be great if you could talk us through an example of maybe a current or a recent challenge that your team has taken on, and just let us get into the brain of an AI expert. How do you think about some of these real world problems as having answers buried in data?
Yeah, that's a fascinating question. Like, I mentioned that this is in the domain of e-commerce, and e-commerce is definitely not a new thing. Like, Amazon has been doing it for at least 2 decades. But Instacart does have its uniqueness because we send shoppers to the physical stores to pick up, groceries or other items. And this is a very, very important part of the business, right? One thing we really want to do is how do we make our shoppers' life easier? So, for example, if we send someone to a grocery store and asking him to pick up 10 items, how do we help him find items as fast as possible to just save his time, right? Unfortunately, the retailers don't really tell us like exactly where each item is located on which shelf. We don't have that kind of information, right? But what we have is many of our shoppers, they shop in the grocery stores. When they pick up one item, they actually need to scan the item before they put it into their shopping cart. So what we have collected is the time stamps, like, after 5 or maybe 20 seconds, you pick up a piece of bread, you picked up, some jam or whatever, right? So we have this kind of information. So one problem is like, how do we use this kind of information to sort of figure out where things are located in this physical space? There's a similar problem in the very, very different domain. So assuming you are deploying many sensors on a mountain or in a very large space area, right? And but you don't know where they are, right? All you know is like, you have a device, and how long does it take for the signals to come back to your device from different sensors? And you have this kind of, information about the time does it take to, ping one particular sensor, and how do you recover the location of sensors through these, timestamps, right? So it turns out it's kind of similar to the problem we are facing. We also have these items in different places, and when the shopper picks up one item, he actually sends out a signal, how long does it take to go to the next item? So putting all these information together, we actually will be able to figure out maybe not exactly the location of the item, but a rough understanding of how things are, where things are located. And this help us to, help our shoppers to pick up stuff more efficiently.
So in the digital world, in networks, we try to build topology maps by looking at net flows. I never thought about it as it's analogous to what you're doing with data from shoppers and the time between the scans and the items that they scan.
Yeah, so it is really a very interesting synergy. Of course, a lot of things. There are also lots and lots of challenges because imagine in this analogy I mentioned, you have sensors in the open space, but these signals they travel in a straight manner, right? They travel the direct distance. But in a shop, in a grocery store, you have those shelves and the items are on the shelves. They usually the shoppers don't go to. They cannot cut through the shelves to go to the item directly. They need to move around those shelves and all these kind of things, which makes things actually much more complicated than the open space.
One of the themes that comes up on this podcast frequently is the impact of biased data. Now, let me try on one scenario for you. Is it possible that Instacart, based on the common scanning patterns, Instacart might recommend alternative items that tend to be more popular or more represented in the data, and thereby some items that might be lower on a shelf, higher on a shelf, less conveniently located might be less likely to be recommended as, let's say, an alternate item if one item is out of stock? Is that a possibility for how biased training data might impact Instacart?
We don't do anything like that. When we recommend items, we basically make the recommendation totally based on, how likely he will like this item as a replacement. None of the information such as, how easily this item is located, how popular this item is, how likely it is, out of the stock, all things like that are taken into consideration. So basically it's all about the preference. How likely the customer will really like this particular item as a replacement.
When you're making recommendations, do you take things like regional differences, demographic differences, age, gender, race? Do those things factor into the recommendations that you make?
We don't. We don't explicitly take into consideration any of these, but we do take into consideration the past purchasing behavior, like what are the items you previously bought. That is the only information we are taking into consideration.
Now, before we start recording, you made an interesting comment about the difference between applying AI and machine learning explicitly in a digital environment versus a physical environment. Maybe if you could explain maybe what you meant by that and what are the additional challenges of applying the principles of AI to physical environments.
It is much, much more difficult to make our physical world smart. We have made a lot of progress in the online world. Now, Google is very, very smart. Like, they can help you complete your sentence when you are replying an email, right? So, but everything is online. But, in the real world, like I was with WeWork and we would like to, make the physical space more friendly to to the people, right? But it's very, very difficult. Like, people are saying, what is the biggest innovation in the physical building? Up to now, it's actually the elevator. But elevator was like invented like, a century ago. So there's not that much innovation in the physical world because of many reasons. And one of the reasons is like, it's very difficult for the physical world to communicate with us or with our algorithms. That is also the reason why, it is so difficult to build a driverless car and have very, very high, 99.99, level of safety record for an algorithm like that, because our environment is not smart. We cannot really, the machines, our cars cannot really communicate with the environment to understand what's going on in the environment or with the cars that are surrounding it or anything like that. So this really makes things much more difficult than in an online world, right? And also there are some other practical issues which makes things very, very difficult in the physical world. In order to get all these signals, because the first thing you need to do, like if you want to make some change, automate things, the first thing you need to do is to be able to measure things, right? But in order to measure things, you need to deploy all kinds of sensors in the real world. That is a very, very expensive thing to do. And improving the sensors, creating new types of sensors is much, much more costly and takes much, much more time than just, writing a new piece of algorithm, right? So all these things add up, makes it really very, very difficult to have a real, machine learning and AI support in the physical world than in the online.
Now, speaking of the bridging the gap, so to speak, between the digital and the physical world, you've written extensively about e-commerce, search, and potentially how natural language processing or NLP might apply to it. I think we both agree today that the process of doing information retrieval, let's say for your former employer, Amazon, it's fairly crude. There's not really a semantic understanding of what you're asking for. Is that going to change if you fast forward 5, 7, 10 years? What do you think that what we call a search experience will be like in the digital space?
There's still a long way to go for e-commerce companies to improve their interface to a certain level that will make the e-commerce experience enjoyable and delightful. There's really a long way to go, right? At this time, I think major e-commerce companies, including Amazon, they cannot even answer some very, very simple, straightforward questions, right? A lot of people still need to go to Google to search for things to figure out, what they want to buy, and then they will go back to Amazon to place an order. So, this is basically the reality. But there's a lot of potential for e-commerce companies to build a better search engine, because that will bring a lot of business to them. So for example, if you search for something like, if you cannot fall asleep at night and you search for insomnia on Amazon, what you like to have is like all kinds of solutions that will help me with this problem I have, which is I cannot fall asleep. So, and apparently Amazon has lots of solutions that can help me with this problem. Amazon can recommend me, some books that I can read, or maybe, some lights that are more helpful for people to fall asleep, or some things I can drink before night, or things like that. So many products are connected in various ways to this problem I have. But right now, it's not there yet. Then the other thing is like, in order for this to happen, we actually need to go beyond just the common NLP, technology that people have been talking about. We need to build a pipeline of algorithms and models doing tokenizations, entity linking, all the way to maybe question answering. there's one big piece that is really important for us to build a better e-commerce search is actually the knowledge base, the product knowledge graph. We need to really understand how things are connected to each other. The causal relationship for one thing to go to the another, right? And you can imagine things like, the thing I mentioned, like insomnia, is nothing more just like one node, one concept in this knowledge graph. And then from there, if you explore the graph, they will tell you in which way this concept or this symptom is connected to various other concepts or other products, right? And then you will be able to make recommendations to your customer. Like when you search for insomnia, what are the things I will show you and why? And if you are able to do that, I think this is really going to be quite fascinating. This could mean a lot of business for e-commerce companies.
I couldn't agree with you more. I feel like the elusive goal to pass the Turing test has distracted so many NLP engineers from taking a more pragmatic approach to some of these simple search problems. You mentioned, the knowledge graph and the example of insomnia, perfect example of where, quote, passing the Turing test would add little sense of intelligence to that,
Yeah.
to that example. What I really want is, like you said, to fan out and look through kind of adjacent nodes to introduce me to the kinds of solutions that I might have, or that might be related to me, the middle of the night, whatever, maybe the pollen count, I have allergy, who knows what, but there's probably a much more intelligent set of nodes than just trying to demonstrate that, I quote, have some kind of crude understanding of what you asked.
Yeah, exactly. I think another fascinating thing about the e-commerce is like social commerce. People, forming some kind of communities when they are doing their shopping. And this actually is going to be driving e-commerce in a very, very different but very innovative ways, right? And this also applies to, for example, grocery shopping, because grocery shopping is a little bit different from like buying electronics. For grocery shopping, you are shopping for ingredients from which you might want to create something, like a dish. In other words, you are actually looking for ideas. What kind of things you can make out of these ingredients? If a website, if an e-commerce search engine can help provide ideas to our shoppers, it's going to be really, really very useful. But then there's the problem again, right? You can think of this e-commerce as as a magazine, like with editors, with human editors. They come up with ideas, they present those ideas to the shoppers. But this way, it's very, very difficult to scale. So the idea is like, can we use social commerce to enable everyone to contribute ideas so that other people can learn from their fellow shoppers, and to create things, new things out of the items they are buying. This is one way to make the shopping experience more interesting and make the entire experience more enjoyable.
Is that a problem you think will solve in the next 5 years?
Well, I think this is quite solvable. I think social commerce is actually quite hot in China right now. There's a lot of e-commerce websites, e-commerce companies in China are pursuing social commerce to use content to drive up the engagement. And then with the engagement, they drive up the business.
So we only have a few minutes left. It's gone by so quickly, but I got to get in at least one last question. That's what's your proudest accomplishment in your professional life? You've done so much, and I know you're young, so you're just getting started. But would love to know, to this point in your career, what are you most proud of?
We talked about knowledge graph. About 10 years ago, I was working on something we usually call a concept net. The simplest way to describe a concept net is that it's just a graph of is-a relationships. So is-a relationship basically is like, Google is a company, US is a country, Python is a cold-blooded animal, but also Python is a programming language. So this is a relationship. If you organize these relationships into a graph, and that basically formed the basis of a concept net. So why concept net is important? Really, it's because this is how our brain organizes the things in the world. So for example, I'm talking to you and assuming I saw something on your desk, which I've never seen before. I have no idea what it is. So I ask you, what is that? And you told me, oh, it's just a cup, right? It's a cup I have never, but just with this concept of cup, I suddenly know everything about this item. I know it's supposed to hold water. I supposed to be able to drink from it, and all these kind of things will follow. Psychologists actually have studied this problem, worked on this in this area for decades. I remember 10 years ago, I was reading this book by a NYU professor whose name is Greg Murphy. And the name of the book is a big book of concepts. It talks about all the fascinating ways our brain deal with concepts, but all the experiments they did and all the discoveries they made are totally based on very, very small scale subject tests, like a questionnaire answered by a dozen people. So what I was really trying to do at that time was really, I want to use data-driven computational approach to investigate those concepts, to redo these experiments they did with just a few people, like, as a subject test. I want to use data to show the results, or to validate the conclusions they have. Turns out we can do that, and I published quite a lot on these topics many years ago. But recently, this problem becomes even more interesting, really because of neural network embeddings and distributed representations, language models, but there's also a very interesting question, which is how do we combine the two? You have the explicit knowledge, and you also have the implicit knowledge, like a black box represented by those, embeddings. So if you put these two things together, actually, this could be a very, very interesting research area, and I expect a lot of interesting things will come out of it.
We'd love to have you back to talk about that when that notion of a concept net is fully commercialized. We'll give you credit.
Thanks.
Well, I told you that was the last question, but how about one more? We were talking about our kids and how we've made it through the pandemic. Share with me, what is your pandemic hobby? What has gotten you through the quarantine?
Oh, that's a good question. I actually have been doing quite a lot of reading. I always wanted to pick up something like a big reading project. So, I think I started at the end of April, beginning of May. I started reading this book by Marcel Proust, In Search of Time Lost. I don't know how many volumes I can finish, but I ended up only finished the first volume, but I get to read it twice. I just want to go back and to refresh myself. It's a fascinating book. It makes you think of a lot of things. So I totally enjoyed it. So this is my COVID project.
Sad to say, you probably have another few months before we're all vaccinated.
Maybe starting the next volume.
Exactly, the next volume, and maybe a bit ironic that you're reading about time lost.
Yeah.
In the middle of a period when we're all trying to contemplate the time that we're losing. I'll add that to my reading list. Hey, Haixun, we're out of time, but this has been so enjoyable, and I hope you will take me up on the offer. Come back. I think we got through about half of the topics that we had planned, but so much fun. I'm glad our audience got a chance to meet you.
Yeah, I'd love to. Really nice talking to you. Thanks.
Likewise. Well, thanks to everyone for listening. This has been another fascinating discussion with a fascinating guest. We're back next week with another conversation. Dan Turchin, AI and the Future of Work, signing off.